Low-level significant weather charts are absolutely essential tools for your flight planning success. When you are planning flights between the surface and 10,000 feet, these charts provide a precise and incredibly structured look at all the meteorological phenomena you can expect across your route. Here in the United Kingdom, we call this the Form 215, or simply the 215. It's generated every 6 hours, 365 days a year, specifically for pilots flying low-level over the UK and surrounding areas. You'll also find the issue time, the duty forecaster, and handy contact details right on the chart. Each chart is released about 5 hours before its validity period begins, and it stays current for a full 9-hour block. The exact validity period is always highlighted clearly at the top of every chart. For instance, look at this example. It's valid starting at 1400 Zulu on the 10th of January, running all the way through to 2300 Zulu that same day. Take a look at the left side of the chart to find the schematic map. Think of this map as a snapshot in time, illustrating the positions of fronts and various significant weather phenomena, all neatly sectioned off using black scalloped lines. Any high-pressure centers are marked with a small circle and an H, while low-pressure centers are clearly identified with a small cross and an L. The specific time this forecast map is valid is conveniently displayed right beneath the chart's title. In our example, we are looking at a chart valid for 10th January at 1800 Zulu. This chart utilizes standard weather symbols, many of which you've likely seen before. Take a look here at this handy list of codes and symbols. I highly recommend spending some time studying this, as committing these symbols and codes to memory will serve you well in the cockpit. Now, let's zoom in and take a detailed look at the map. As we've discussed, frontal boundaries and significant weather areas are clearly marked for you. You'll notice these weather areas are neatly bounded by black scalloped lines, or sometimes by the edge of the map itself. Each area is easily identified by a boxed letter. In this specific example, our map is divided into 6 distinct areas. Each of these areas is linked directly to the text in the main body of the chart using its designated letter. You'll see arrows indicating the direction of movement for both fronts and area boundaries. Those numbers right next to the arrows represent the speed of the feature in knots. If a front or boundary is stagnant or moving at less than 5 knots, you'll see the word slow noted alongside. Let's dive into the text information provided on this low-level significant weather chart. Just as we noted, this forecast information is tied to the specific areas on the map via those letter codes. For each area, you'll find 3 distinct columns of information. The first column breaks down surface visibility, weather phenomena, and the frequency and distribution of that weather. The second column outlines the forecast cloud cover and any associated hazards you need to be aware of. Finally, the third column details the forecast freezing levels. Let's focus our attention on Area A and examine that first column to see what the surface visibility and weather forecast looks like. The first line of text outlines the general conditions expected across that specific weather area. In this example, we are looking at a surface visibility of 30 kilometers with nil significant weather. Keep in mind, though, that some variations may exist within Area A that differ from those general conditions. We find more detail on these variations listed below the general info, using standard abbreviations for widespread, frequent, occasional, isolated, and localized phenomena. This is followed by the visibility, the weather phenomena, and precise details on exactly where or when to expect them, such as along the coasts, overland, or near hills and mountains. To keep things consistent across all your briefing tools, the coding used in the significant weather chart is very similar to what you see in METARs and TAFs. I've included this table here as a quick refresher for those codes. Now, let's roll up our sleeves and decode the surface visibility and weather for Area A together. As we noted, the general condition for Area A is a visibility of 30 kilometers with nil weather. However, watch out, occasionally, visibility will drop to 7 kilometers with moderate rain showers. In isolated areas out west, expect visibility to drop to 4,000 meters with thunderstorms and moderate hail beginning at 2,100 Zulu. Locally, around the mountain ranges, visibility will dip to 800 meters with moderate snow showers. Generally, we are looking at moderate turbulence, but be aware of widespread severe turbulence to the north. Lastly, keep an eye out for hill fog in isolated areas. Remember, as shown in our legend, hill fog implies a visibility of less than 200 meters. Moving on, the second column of the chart covers forecast cloud layers and any associated weather hazards. Just like with the surface visibility, the first line of the cloud forecast provides the general conditions for the area, with specific variations detailed in the lines below. The first element you'll see is the cloud amount, expressed as few, scattered, broken, or overcast. Next up is the cloud type, using the standard aviation abbreviations shown here. And finally, following the cloud type, you'll find the icing or turbulence hazards. You'll find the codes for these right in the legend as a handy reminder. Next up, we look at cloud information, specifically the base of the clouds, which is expressed in hundreds of feet above mean sea level. Followed by a forward slash, you'll see the cloud tops, also expressed in hundreds of feet above mean sea level. At the very end, keep an eye out for additional details regarding exactly where and when you might encounter specific clouds or hazards. Now, let's roll up our sleeves and fully decode the cloud information for weather area A. Generally speaking, across this area, we are looking at scattered to broken cumulus and stratocumulus clouds. Keep in mind, this setup brings a risk of moderate icing and moderate turbulence right within those clouds. To get the full picture on the icing layer, always be sure to cross-check the freezing levels for the area. You'll see cloud bases ranging from 1,500 feet to 3,000 feet above mean sea level. As for the cloud tops, they range from 7,000 feet up to, and even exceeding, the chart's ceiling of 10,000 feet above mean sea level. In isolated areas, watch for cumulonimbus clouds with bases at 1,500 feet and tops reaching above the chart level to the west, starting at 2,100 Zulu. This is a crucial point for your safety. Whenever cumulonimbus clouds are indicated, it implicitly warns of associated severe icing, severe turbulence, and hail. Moving on, the final column of the chart provides the freezing level information. This part is quite straightforward to decode, as it's simply provided in hundreds of feet above sea level. For instance, in Area A, the freezing level is forecast to sit between 4,000 and 5,000 feet. In Area B, however, the freezing level sits between 6,000 and 9,000 feet, though it drops as low as 3,000 to 5,000 feet in the far northeast. Now, notice a unique weather phenomenon tucked into the freezing level information for Area D. You'll see the main freezing level is at 5,000 feet, but there are actually sub-zero layers of air over land extending from the surface up to 1,000 feet. Down at the bottom of the chart, you'll find a brief summary outlining the outlook for 12 hours beyond the 1800 Zulu expiry of the main map. While this outlook doesn't provide precise cloud heights or specific phenomena, it gives you a great indication of how the synoptic situation is expected to evolve. There is one more key element that isn't directly on the chart itself, but you can easily find it right below the chart on the Met Office website. This extra piece of information is known as a prognosis. Essentially, the prognosis provides a surface pressure chart valid for 6 hours after the main chart's validity time. Taking our example map, if the main chart is at 1800 Zulu, then 6 hours later brings us to midnight. So, as you can see, the chart time for that prognosis would be 0000 Zulu. Before we wrap up this lesson, it is definitely worth taking a closer look at a few specific forecast details that deserve a bit more explanation. Occasionally, when meteorological conditions warrant it, you will see an area divided into smaller subareas. For instance, on the map here, you can see both Area B and Subarea B1. The reason we use similar labels is that these areas share most of their characteristics, though they may have one or two distinct differences. Let's dive into the forecast information for these areas to see how that works. The general conditions for Area B, and by extension B1, are 15 kilometers of visibility with either nil weather or perhaps some light rain. However, keep in mind that throughout these areas, visibility will widely drop to 7 kilometers with moderate rain. In isolated pockets, expect visibility down to 4,000 meters in heavy rain, though this is primarily focused in the far north of Area B and throughout B1. The next few lines of the forecast don't apply to Area B1 simply because that subarea lacks a warm sector, mountains, or hills. It is really important that you understand the next two lines of text. Since there is no specific qualifier for the frequency, you must assume this weather is a general condition for the entire area.